Okay, guys, so over the last couple of days, we talked about solving a system, building a system for two unknowns. Remember that a system of equation is just when you have more than one unknown variables. Just think back to the activity we did with the layups and the free throws. Well, here's an example of the solution point for the equation. So you guys can quickly tell that 1, 2 is right here. It makes both of these equations true. You can quickly test this like so. If I put in 1, I should get an output of 2. 2 times 1 is negative 2 plus 4, that equals 2. Same thing for this one. The second equation, put in 1 for x, and I get 2 is equal to 2. So this just means that this point satisfied both equations. It makes both statements true. Today we're going to be talking about substitution method. Sometimes you'll see the phrase symbolic manipulation. We kind of talked about that at the beginning of the year. Symbolic manipulation just means, hey, solve it algebraically, manipulating each of the variables from side to side. We can also find systems of equation by substitution. I talked about in class substitution as in, for example, if I'm not here, you'll have somebody to stand in my place. It's the same thing. You can actually use variables and expressions from another equation to substitute it into this one. So here's a perfect example of what I'm talking about. In this case, y is equal to 2. So evaluate this. We're going back to 6th grade and 7th grade. So if y is equal to 2, I'm going to substitute it right there. So I get negative 2x minus 3 times 2 equals 6. So I do my orders operation, negative 2x minus negative 3 times 2 is negative 6 is equal to 6. Add 6 to both sides. I get negative 2x is equal to 12. I divide both sides by negative 2. And x is equal to negative 6. And if I put that in negative 6, and that's 2, that should all work out. They should all equal, the left side equals the right side. Okay? So it's the same thing today with the substitution method. Instead of having just a number, though, you're going to have something that looks like this. To solve a systems of equation using substitution, here's an example. 3x plus 2y is equal to 14. And y is equal to 2x. This could be viewed as a system. You can graph each of these, you can change this into standard form, do your calculator function, but that takes a while. So let's just solve it symbolically using algebra. Okay, we're not graphing today, we're going to do some math. So here's a y, and just like in the last example, here's also a y. So what I can do is, if y is equal to 2x, I can take this entire 2x and substitute it in where I see y in my first equation. This is equation A, this is equation B, equation A, equation B. I can technically take this 2x, put it in for y, because I already see that in my system y is equal to 2x. Zoom out a little bit. So let's just rewrite what happens after I substitute, just like I did in the last example. Y is equal to 2x, so I write, here's my equation A. 3x plus 2 times, instead of y now, I write 2x is equal to 14. And then I do my orders operations. 2 times 2x is positive 4x. Bring everything else down is equal to 14. Simplify, 3x plus 4x is 7x is equal to 14. I divide both sides by 7. X is equal to 2. But that's only my first variable, my x. I also need to find what y equals. But I already know that x is equal to 2. So what I am going to do is take this 2. Whoops, sorry guys about that. Take this 2, and I am going to substitute it back in to either of the original equations that they gave me to figure out y. I will go ahead and do the easiest one to do is b, because b is just y is by itself already. So what I'm going to do is go, okay, equation b down here. camera, says that y is equal to 2x. That's from my original statement that they gave me. I know that if x is equal to 2, now I resubstitute it back in. Y is equal to 2 times 2. Y is equal to 4. And now I have my ordered pair, 2, 4. Last step. After you get your ordered pair, just like we did in class, put 2 in for each x value, and you should get 4. So let's do this one right here. We just did the bottom one, y equals 2x. Y equals 2x, it gets 4, so I know that's good, that's check. Okay, so let's do for the second one, or equation A. Equation A, I'm going to check now using 0.24. 3, instead of x, I'm going to write 2, plus 2 times, instead of y, I'm going to write 4, equals 14. Mathematically, 3 times 2 is 6, plus 2 times 4 is 8, 14, and 6 plus 8, 14 equals 14. Check. So I know that 2, 4 is definitely my solution point. This is my solution point for this equation or this system. Okay, now remember, if I'm going too fast, pause the video, write down the steps, and replay it. Okay, let's do one more example. Solve using substitution method. Check your work. I get y is equal to x minus 1. I get 2x minus 3y is equal to negative 1. I'm going to go ahead and use equation A, equation B. I'm going to go ahead and use this one to substitute into this one because y is already by itself. You always want to choose the one that you can play with that is a little bit more manageable. So y is equal to x equals 3, 1. I'm going to take this entire quantity, x minus 1, this expression, and substitute it into my second equation where I see y, since I already told me y is literally equal to x minus 1. So I rewrite it. This is equation B. 2x minus 3. The number 3 stays the same. That's the coefficient. But y changes to x minus 1 is equal to negative 1. From here, do your orders operation. Since you have an expression here, you're going to have to do the distributive property. So negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. Bring everything else down to x. Instead, 2x. So now I have 2x minus 3x plus 3 equals negative 1. And then from here, combine like terms and solve. 2x minus 3x is negative x, or for some of you, you like to see it as negative 1x. That's the same. Plus 3 is equal to negative 1. And then I just, from here, solve symbolically. So I minus 3, minus 3. I get negative x is equal to negative 4. And I do not have a negative 1 in your final answer. I don't want that. So what I'm going to do is, since this is negative 1x is equal to negative 4, this is technically saying the opposite of your answer or variable x is negative 4. I'm just going to divide both sides by negative 1. X is positive 4. I am not finished. This is one of the biggest misconception that many students start having when they're solving systems. They think they get one answer and they circle it and they move on. Remember, you're actually looking for the solution point. So in order to find the solution point, you have to take the first one that you found and you're going to have to put it back in. You're going to have to put it back in into one of your original equations. So I'm going to put it in to this one. Since I played with this one already, I'm going to substitute 4 back in for equation A because y is by itself. So here's my equation A. Equation A says that y is equal to x minus 1. And I already know that x is equal to 4, so what I'm going to do is substitute it back in. I get y is equal to 4 minus 1. I get y is equal to 3. And my ordered pair here that I have is 4, 3. Not finished. Now we need to check our work using 4-3. So I'm just going to go ahead and rewrite it. 4-3. Equation A in my system was y equals x minus 1. Equation B was 2x minus 3y is equal to negative 1. And just like we did in class, is this a solution point for both of these? So I'm going to do it over here. 3 is equal to 4 minus 1. 3 is equal to 3. That checks out for equation A. Equation B, 2 times 4 minus 3 times 3 is equal to negative 1. 2 times 4 is 8, minus negative 3 times 3 is 9, negative 1. 8 minus 9, negative 1 equals negative 1. Checks out. So, yes. Okay, so that's the substitution method. Please, you might have to rewatch this a couple times. That's okay. We're going to practice this a lot in class. I just want to get you guys the basic skills of taking one equation and substituting the other one. Make sure you guys with this, and make sure you guys rewatch this if you need to. Okay, we'll go over it in class. Thanks, guys.